Here are our objectives for section 3.3, which is dividing polynomials, remainder theorem, and factor theorem. Excuse me. First of all, we need to be able to use long division. We need to be able to use synthetic division. We need to evaluate a polynomial using the remainder theorem, and we need to use the factor theorem to solve a polynomial equation. Okay? So let's start off with some long division. Okay? Long division of polynomials is pretty straightforward. I'm going to take you through this problem just in case. Okay? We start by taking the first term on the inside and the first term on the outside. What is x squared divided by x? I know there's all the rest of the stuff in here, and I know there's this right here also. We only care about first terms. So what is x squared divided by x? X. Now multiply x times x. X squared. Multiply x times 3. 3x. Now, normally we would subtract. When we're doing regular long division, right here we subtract. What we want to do is change our signs and add. Isn't changing the sign and adding the same thing as subtracting? But we think of it as changing the sign and add because we have to change the sign of each term. Okay, if all I do is say subtract, a lot of the times you're going to forget to subtract that second term. Okay, so we're changing the signs and adding, which really, I guess mathematically what we're doing is multiplying this whole thing by -1 and then adding. Okay, so that's 0, and that is 7x, and then we bring down what we have left. And now we start all over again. What is 7x divided by x? 7. What is 7 times x? And what is 7 times 3? 21. And we change our signs and we add. 0. Does that make sense? Long division? Do I need to do any more of those? You got it? Okay, you remember that? Well, we are going to do one more only because that one was a pretty easy one. Okay, that was a pretty easy one. This one is a little bit more involved. Okay. The other thing that I want to talk about specifically is on this particular problem, there's some missing terms, and we need to decide what to do about that. Okay. We start with x to the 4th. Do we need to make sure there's a place for everything below that? We kind of do. Okay. 6x to the 4th plus 5x to the 3rd. We don't have an x squared term, but we need to make an x squared term. So I'm going to put in 0x squared, because that's the only thing I can add to a problem without changing its value. Okay? And then 3x, and then minus 5. So make sure you have those placeholders there for terms that you need. All right? Now start from the beginning. Divide the first term on the inside by the first term on the outside. What's 6 divided by 3? 2. What's x to the 4th divided by x squared? So 2x squared is what I have first. 2x squared times 3x squared is 6x to the 4th. 2x squared times 2x is 4x to the 3rd. Thank you very much. That's a minus right there. Then we change our signs and we add. Well, that's 0. Will this ever not be 0? It's not going to ever be anything else but 0 unless you've divided wrong to begin with. Okay? So that's 0, and that is 9x to the 3rd. Then we have 0x squared and 3x and 5. Okay? So divide the first term here by the first term here. 9 divided by 3 is 3. X to the 3rd divided by x squared is x, so 3x. 3x times 3x squared, 9x to the 3rd. 3x times negative 2x, negative 6x squared. Now we change our signs and we add. That's a 0. That is 6x squared plus 3x minus 5. Now how do I know when to stop? How do I know when I'm done? Well, can I still divide this by this? I can, right? So I keep going. Okay? So this is 2. 2 times 3x squared is 6x squared. 2 times negative 2x is negative 4x. Change your signs and add. 7x minus 5. if you notice me ever doing long division, you're going to notice that I always change my signs with a different color. Okay, that tells me, that's a visual clue for me, because I'm a very visual learner, very visual worker. It tells me that I did change my signs. I never have to worry or guess, especially if I get involved in a conversation right in the middle of the problem. I can go back and say, oh yeah, I changed my signs already, and keep going from there. Okay, now what? Can I divide this by this? No, I can't. This exponent is lower than what I'm dividing by, so I'm done. So this is my remainder divided by what I was originally dividing by. Okay? So this right here is my solution. Does that make sense? Any questions about this? So what if I did have a division problem like this, but I'm dividing by x plus 2? Or like the first problem, x plus 3. Well, is there a shorter way? Yes, there is. But it only works when you have an exponent of 1, like this is, x plus 2 or x minus 3, like that other problem. And with these kind of problems, you can do synthetic division. Okay? Synthetic division, remember, looks like an upside down division sign. It's even more important that we have the placeholders if we need them. So I have a 5 here, and then a 0 because I don't have an x squared term. Then I have a 6, and then I have the 8. And underneath the 8 goes my remainder box. Okay? If this is what I'm dividing by, what goes out in front of the synthetic division problem? Do you remember? -2. Because really what I'm doing is I'm taking this factor and looking for the solution. And I do that by subtracting the 2 from both sides to get x equals -2. And whatever it equals is what goes out here. So -2 right there. Now here's the pattern to remember. Okay? Bring the first term down. No matter what it is, bring it down. Multiply these two numbers. Write the answer right here. And now add. Then start again. Multiply these two numbers. Write it right here, and now add. Multiply these two numbers, write it right here, and now add. What do you think? Do you remember synthetic division? Yeah, that's we have to write the answer next, right? So this is the remainder. The one right beside that is the constant. The one right beside that is the x term, and the one right beside that is the x squared term. So you are correct. It is 5x squared minus 10x plus 26, and then plus -44 over x plus 2, because that's what I was originally dividing by. Now, this is a little quirky sometimes, so I want to make sure that you understand this. There is no difference in these answers at all. But one of them the computer likes and one of them the computer doesn't like. And I have to be honest, I don't remember which one it is. I'm thinking it's probably this one though. Okay? It doesn't like this one. I think it likes this one. Okay? But just keep that in mind. Okay? Now, sometimes people are like, really, is synthetic division that much shorter and faster? Well, let's go back to this very first problem we did. This would be -3. This one would be 1, 10, and 21. 1, -3, 7, -21, 0. X plus 7. Guys, that was way faster, wasn't it? Okay, so synthetic division, if you can do it, it's typically a lot faster than long division. Okay, when can you do synthetic division and when can you not do synthetic division? You don't remember? When what you're dividing by has the exponent of 1, right? The highest exponent. We can't do synthetic division on this one because it has a squared. Okay? We could only do synthetic division on problems like this. X plus 2, x plus 5, x plus x minus 4. Could I do 2x plus 1? Yes, because of my degree, my highest exponent is a 1, and that's okay. Now, in order to put the number out here in front, I'd have to solve this one for x, and I'd end up getting a fraction, but it's still possible. Does that make sense? Okay. So that's long division and synthetic division as far as our objectives go. Okay. Next, we need to be able to evaluate a polynomial using the remainder theorem. Well, in order to be able to evaluate a polynomial using the remainder theorem, you got to know what the remainder theorem is. Okay. The remainder theorem says if the polynomial f of x is divided by x minus c, then the remainder is the value of the function when you evaluate it at c. Okay? Here's what I mean. I'm going to go back to this problem right here that we did very first. Okay? The problem was x squared plus 10x plus 21 divided by x plus 3. Now, we did the long division here, right? Okay? And we did the synthetic division here. And both times we got a remainder of 0, right? Just happened to be a remainder of 0 here. What the remainder theorem says is if I'm dividing by x minus c, so this would be x minus a negative 3, right? Then the remainder is f of c. So I need to evaluate the function at c. So if I take f of negative 3 for this problem, for x squared plus 10x plus 21, what this theorem is saying is that my answer should be 0. Okay? Because when I did the long division and synthetic division both, my remainder was 0. So if I evaluate this function right here at negative 3, I should get a 0. Negative 3 squared plus 10 times negative 3 plus 21. Well, negative 3 squared is 9. Minus 30 plus 21. Guess what 9 minus 30 plus 21 is? 0. That's the remainder theorem. Any questions about the remainder theorem? Okay. Then our last objective today is to use the factor theorem to solve a polynomial equation. Once again, in order to be able to use the factor theorem to solve a polynomial equation, you've got to know what the factor theorem is. Okay? The factor theorem says that we're going to let f of x be a polynomial. So if we evaluate the function at c and that equals 0, then I know that x minus c is a factor. Also at the same time, if I know that x minus c is a factor, then I also know that the value of the function at c is 0. Okay? So once again, going back to that same problem we did very first, because my remainder is 0, I know that both this, what I divided by, well, let me just start there. I know what I divided by is a factor of this function. Okay? Now, I also know that the answer is a factor, but that's because that's what I got when I divided by it. Okay? But let me show you one more so that you know what I am talking about. It says, solve the equation. Well, I don't know why I put that many bumps in V. Sorry about that. 2x to the third minus 3x squared minus 11x plus 6 equals 0. Okay? It says solve that, but what it also tells you is that 3 is a 0 of this function. Okay? 3 is a 0 of this function. So what I can do is I can do synthetic division or long division to divide 3 into this function. Okay? So 2, negative 3, negative 11, and 6. Bring down the 2, multiply here, add. Multiply here, add. Multiply here, uh-oh, I missed a sign right there, and add. Now, did I know ahead of time that I was going to get a 0 right here? I did, because it told me right here that 3 is a 0. Yes, ma'am. Yes, That's a given. It tells you that 3 is a 0 in the problem. That's a given. Okay? So I knew this was going to be a 0 because it told me that 3 is a 0. Now 0 being where it crosses the x-axis, but it's kind of cool because it also is a 0 remainder. So several different reasons why you could think of it as a 0. Okay? So what it wants us to do from here is to solve the rest of this. We could factor it. We could do any number of things that we know how to do in order to find the other factors of this. But I know one factor already is x minus 3. Okay? So this is 2x squared plus 3x minus 2 equals 0. Right? Because I already have my one factor of x minus 3. You want to go ahead and factor this? AC is negative 4 and B is 3. What multiplies to be negative 4 and adds to be 3? Positive 4 and negative 1. So I have 2x squared plus 4x minus 1x minus 2 equals 0. If I factor by grouping now, I have those first two terms that I see a 2x in common, which leaves me an x plus 2. I notice in the second two terms, what's common is a negative 1, and I have x plus 2. I notice that between these two terms right here, they both have an x plus 2. And if I factor out an x plus 2, what's left is 2x minus 1. So now, starting from the very beginning, if this is my problem, my three factors are x minus 3 from right there, x plus 2 from right there, and 2x minus 1 from right there. Okay? If these are my factors, can't I just easily find my zeros? Yeah, I just set each one of these factors equal to 0, don't I? And I already know this one because it told me from the very beginning that 3 was a 0, right? But now I just say x plus 2 equals 0. So x equals negative 2. That's a 0, excuse me. And then 2x minus 1 dividing by 2 gives me x equals 1/2. And those are my three solutions. Okay? It does ask you to typically write it as a solution set, which means we're using the set notation. And typically we write our solutions from least to greatest. So we would want this in the order of negative 2, 1/2, and 3. Does that make sense? Any questions about the factor theorem? No? All right.